Evaluate the following definite integrals. Okay, so now since we have definite integrals, that means that we just have like a lower and an upper bound for our function, right? So we're going to take the integral of sine x, okay, that's the function, right, in between, and it's going to be from 0 to 2 pi. So unlike we did in the last lesson, we're not going to need to like add up individual pieces and then really like find the magnitude or like the absolute value of each of those pieces to add it up. In this case, it's a little easier because we're just finding like the net result, right? So we're like, we're going to be subtracting anything below the x-axis, so just whatever it comes out as. Okay, so the integral of sine x is just negative cos x. Okay, so then one way to write this, sometimes you'll see with like a line that would say from 0 to 2 pi, and then sometimes you'll see it where there's like a little like square bracket, right? So what this is saying is that the integral of sine x was negative cos x, and now we're going to find this at 2 pi, and then we're going to subtract it at 0. Same thing as like from 0 to 2 pi, right? We're going to go 2 pi minus the 2 pi version minus the 0 version of this, right? Okay, so this will be equal to negative cos, and then, yeah, 2 pi minus, and then negative cos of 0. So this comes out to negative, so cos of 2 pi is 1. So we've got negative 1 minus, and then and then negative, yeah, cos of 0 again. So this will be negative 1. So this is like negative 1 plus 1. So this comes out as 0. And that makes sense, right? Because our function here for sine x, would start at 0. And it would go above the x-axis and below the x-axis, right? And then come to 2 pi. So what we just found is that this area minus this area gave us a net result of no area, right? So we ended up with 0. Okay. All right, moving on. Okay, so we'll find the integral from 2 to 5 of this. So we'll just find the antiderivative of each individual term here. So this would be equal to, so this would be like 2x to the 4 over 4 minus 3x to the 3 over 3 plus 7x squared over 2, and then plus 2x. And then again, what we'll do is we'll just make like a little line here and then say, okay, this was from 2 to 5. So then we'll just fill this in. So we get, this is equal to, and 2 over 4, I'm going to call that 1 over 2. And then I'm going to be putting 5 in for everything first, and then subtracting 2 in for x. Okay, so this is times 5 to the power of 4 minus, this is just x, oh, not x. This is now 5 to the power of 3 plus 7 over 2 times 5 to the power of 2 plus 2 times 5. Okay, so that was our first one. And then we are going to, so that was our first one. And then we're going to subtract the same thing, but with 2 substituted in for x. So with 2 to the power of 4 minus 2 to the power of 3 plus 7 over 2 times 2 to the power of 2 plus 2 to the, or 2 times 5, or 2 times 2. Messing myself up here. Okay, so this all comes out, well, I'll do individual pieces here. So this first term comes out as 625 over 2 minus 125, 5 to the power of 3, plus 175 over 2 plus 10, and then minus, I'm going to keep this in brackets, 8 minus 8 plus 14 plus 4. So this all comes out now as 267. So the area under the curve of this function from 2 to 5 would be 267.